Okay, the last example in this set of lecture notes is example 3.7, and it tells you to find the absolute max or min of y equals 16 minus x squared on the interval from -2 to 4. So the process here is essentially exactly the same as what we just did. The only thing is that you now need to check the endpoints of the interval because you're looking for an absolute max or min over an interval. So we only really care about x values from -2 to +4. And so the first thing you want to do is you want to take the derivative to find the critical values. So -2x is your derivative, so when you set that equal to 0 and solve, you get that x equals 0 is your one critical value. And then we need to figure out whether or not this is a max or a min. Well, the derivative will be positive, so if you take any value to the left, like y prime of -1, then you get -2 times -1 is +2. So we know the derivative is positive, so the function is actually increasing. So f of x is increasing to the left of 0, and then if you plug in a number to the right of 0, you get -2 times 1. So -2 is less than 0, so the function is decreasing over here. So we know the function is decreasing over here. We know that it's increasing over here. And so what does that mean? That means that if a function is increasing and then decreasing, we're going to have a max at x equals 0, is the takeaway there. So let's actually figure out what you get at 0. If you have y of 0, that's going to give you 16 minus 0 squared is 16. So we're going to have a max. We're going to have a max of 16 at x equals 0. And now we need to figure out which one is smaller, y of 4 or y of -2. So now you take y of 4, you compute that, you get 16 minus 4 squared is 16 minus 16, or 0. If you take y of -2, you get 16 minus -2 squared, which is 12. And so the absolute min is going to be 0 at y equals 4, or at x equals 4. The absolute max is going to be 16 at x equals 0. So let me just write that down. Absolute max of y equals 16 at x equals 0, and absolute minimum of y equals 0 at x equals 4. Okay, and so what that means is, like, if we were to draw this, the actual function on the graph here, what that's telling us is that at -2 we have, it's at +12, y equals 12. So maybe I'll do this, 16, 12, 8, 4. So we're starting off at y equals 12. We're going up to 16, and then we're going down to 0 at x equals 4. So over this interval, this is the absolute min value, is y equals 0, and this is the absolute max value. Okay, so we were able to figure out all of that just using the derivative and plugging in values into the original function.